So today we are here to talk about ADAPT. Now, ADAPT is a labor planning tool. I just want to give you a high-level overview of what this tool does. This tool has been designed from ground up. Now, as you know, Accenture is into consulting; it doesn't do products, but this is one of the products which has made come out of acquisition, and I was part of that whole journey from POC to productionization of the product. So right now it's active in a couple of retail industries and it's making a meaningful impact. And what I want to bring to this audience is how AI can help you, machine learning can help you solve industrial problems. So let's get cracking on that. So why adapt? Now, some of the answers are very cliche over here, but you will notice that in the retail sector, like finance, ops, and different people are involved in forecasting. And when they are forecasting, they don't have all the information together with them, and it becomes very difficult for them to put that information together and come up with a forecast. And because of that, they rush things, and it is not that accurate. Then because of that, doing budgets and it takes too long and they're inaccurate, which means they have to take quick decisions, which you talked about, and some of them are not good ones. Similarly, uh, they do a lot of store initiatives. Like every retail organization want to take initiatives that in my particular store, I want to start this activity where I can draw more audience and things like that, or customers. So when they try to do those initiatives, they don't even have the understanding of what impact it is creating. And let's say I started with an initiative, was it giving them meaningful results? Do they need to do more of that activity because it got them more results? So there's absolutely no way for them to get that insight around. And mostly all this information is tracked using Excel and various other data source, which is not adding much value. And plus the managers of the store, when they are looking at data, they don't have any visibility of what is happening. Now, to solve this problem, that's when the next thing comes in, which is the adapt, which comes in to solve this problem. Now, how the adapt as a solution looks like is basically it comprises of a infrastructure as a platform where you can plug in different application, which is forecast and demand. And these two modules are basically nothing but you as the name suggests, forecast. It helps you look into the data and project what the forecast is going to be. And using demand as a solution, which is working on big data, it helps you identify and do calculations about what is your labor planning going to look like. You do a labor modeling in there, and you do what if analysis in there. Now, Adapt is a cloud-based solution. Everything is in there, and the UI is, I mean, it uses all the latest and greatest technology. Like you have a front door, which protects you from external impacts. Then you have all the information flowing in, and you have open API and things like that. And Forecast is a tailored algorithm which we have come up with for machine learning, and that helps you give you a more accurate prediction about your, let's say, metrics like sales. We'll come to that shortly. And also with demand, you can do in a control area and do your what if analysis in there. So that's basically what Adapt is. Moving on, this is what it looks like. Now, here you will see that we have external source of data which comes into the system. And a gentleman over here also talked about that when you're doing any processing, you need to feed in the data in there. And once you feed in the data, it goes to the machine learning element, which will come to the architectural diagram. But before you talk about it on a very, very high level, we're talking about a model training, deep learning, clustering, and bias correction, because bias is also which comes in and you need to do correction in there. This is also one of the important things as part of the benchmarking which you do, is because you have data from various points of time. And we primarily try to look into 5 years in past. And then when the new information comes in, we try to predict on that. And the model has been trained for last 5 years for any organization. So it becomes very easy for us to predict in future. Now you may ask that how would you predict in future? And how do you know that what accuracy you're predicting? And that's when the benchmarking comes in. And what we do over there is, if you are getting for, let's say, quarter 2021 any information, you do a prediction over there, but you also have the actuals. And when you have the actuals, you compare your predicted values, and you identify your mean absolute percentage error. And when you calculate that, you understand how accurate you are. This is a mathematical calculation which happens. And the more, the lower the numbers are, the better you are. We have successfully managed to get to a number of 18, which is, I mean, the absolute best is 10, but to achieve that takes a lot of iterations to go through the model. But we've managed to get to the MAPE of 18 for predictions. And this again varies from retail to retail organization, and there's a lot of configuration and fine tuning of data which needs to happen, especially around um, uh, different models. When you're creating it, you need to pass in that information. And as you know, in the world of what's the term for it? Uh, Hyperparameters. So those hyperparameters are the ones which you need to fine tune them. And then you can, once you've done that for each organization, you can further reuse the same product over and over again. And that's what is done through the machine learning component. And then once the forecast is generated, you can basically get the results like this. As you can see over here, different graphs are generated. Now you can see different colors over there. The one which is in blue is the actual presentation of the value, and the ones which are green are the edited, and the ones which are orange are the actuals which are coming in. So that's when we can compute. If you have the previous value, you're looking into the past and doing predictions from there, and then presenting the values. That's when you can see it. And all this information is then fed into the demand module, which basically does, you first create a labor model. Now, what does a labor model look like? In an organization, let's say you're talking about Sainsbury, you have a labor force of people who are on the till, people who are on the back office, managing all the stock, people who are sending the goods, bringing in goods and things like that. So if in a simplistic world, you model those many people who are going to be there, each person, how much time they take to do their job. You do basic FTE around it. And then what we do is, on a 15-minute interval, we calculate all those values, and then we put that thing against a budget, because every organization operates on a budget. And then we put against that model that, okay, we have this much workforce, you have this much the cost around it, and this is the budget. Now our predictions comes in, and using those predictions you do the what if analysis, because you have the initial hours and the budget created, and then you can create different models around that, and then finally you can see which budget fits it. And that's what is being sent through Power BI or any analytical tooling you have, and you can present that information, which further goes and gets connected to any other external systems like WFM, Workforce Management Solution, like Blue Yonder, Ceridian, or for that matter, uh, which is the other one, um, Kronos. So there are these other things which manages that. Then moving on, what kind of information is going into forecast? There are two types of information which are going in there. One is metrics and one are drivers. The metrics can be a standard thing like items, transactions, sales, SKU levels, and things like that. And drivers are very interesting. Drivers can be external like weather forecast. If you can talk about that, you have weather over here, you can have weather data for short term and you can have long term. Now you may ask, why would you need to use driver like weather to use for forecasting? Sure enough, it makes a difference, because when you are in a retail store, your people coming into the shop numbers changes. When it's a rainy day, you will have a fewer people coming into your shop, and when it's a bright and sunny day, maybe you will have more people. So it based upon the situation. Then it's also longitude and latitude also makes a difference. Like if you have longitude and latitude which is closer to a point of interest, and that's where the point of interest data comes in. If you're closer to a, let's say, um, um, let's say a university, or you're closer to a shopping center, in that case you may have a footfall. Your footfall may vary based upon location to location, because nobody, if you're in a closer to a garden, then your chance likelihood somebody coming to your place is much lower, because people will have to spend time over in a garden. So things like that. Similarly, if you have a renovation in location happening in your store, you don't want you won't have anybody coming in because it's an inconvenience for people, and why would anybody come there? So you need to analyze that data around it. Similarly, you have store characteristics. If you have a small express store, the number of people coming to your place versus if you have a supermarket or a superstore or a hyperstore, the number of people coming in and the footfall will change. So all these are different drivers which basically tell you that how this can influence the number of transaction, items, sales, SKUs, and everything around that. And that goes into, of course, we're using APIs and things like that. We're using all these information to feed in. We started with an open API, but then we can integrate through external systems, which further feeds in, and it becomes a seamless system which goes into the forecast engine. And then forecast engine, as you know, goes into demand. We're not going to talk about much on demand because the machine learning element sits in the forecast side. So we'll dig deeper around that. Any questions around this before we move on? Yeah, go ahead. Yes. Mm-hmm. Yes. Well, I mean, Accenture looks into bigger organizations and they would like to charge accordingly. So small organizations won't able to be foot the bill because to stand up this, I mean, it's a product to set it up and configure. I talked about hyperparameters and things like that. So we need to do a lot of analysis around that with data scientists and then fine tune the model and then publish it. And to do that, there is a lot of cost which I don't think mid-size or smaller companies could afford. This is only for companies like Sainsbury's or Marks and Spencers and things like that. They would be more beneficial for them. Oh, that way. Yes. Right. Yeah, there is a possibility of collaboration with Shopify and to see that because online sales and transactions are also nothing different than this, which acts like a driver, metrics which can go into the system, and then you can know that how many people you're expected to come for Black Friday, or how many people you're expecting to come on a regular basis, and what events do you, or what promotions you need to do on website to bring in more, attract more. Of course, you can do that, but that's not the premise with which right now Accenture is going with. But yes, there is a potential in there for sure. Okay, moving on. So, so this is how it looks like on a very, very high level. You see the forecast where you can see the predictions being done. Now, these predictions on are basically is done through a Angular web frontend. Then there is an application gateway which sits in there. We have different API services which are communicating. There is a database which manages all the authentication and authorization and stuff. Of course, application insights, which stores the information. And then further, it comes through the forecast API, which sits here. Of course, we have demand and stuff, which is separate. So I'm just focusing on forecast right now. And that in turn, we have some Azure functions which do background processing. And this is where the machine learning element sits. We talked about in machine learning element, it's very important that when you send the information into the machine learning component, you need to normalize the information. Once you normalize it, it goes through the various layers. The layers are such that you need to identify what, when you're creating the data frame, you're bringing in the data for each. Think of it that we're plotting the data frame for each store. So each store is basically each row, and for each row you have data being collected, and each driver is basically each driver, and each metric is a column. Think of it this way. You further normalize that to make it consistent across each store so that you can compare apples to apples. because it's not fair that if it's a smaller store or it's a larger store, how would you compare that? That's when the normalization happens. And then you add features. Now, how would you add features? You would add different features like weather. You can add features like point of interest. You can add features like economic factors. Economic factors are like what is the uh, uh, what is the economical situation, and based on that you can add that. Now in terms of weather, you don't capture each and everything of weather. What we've analyzed that there are certain attributes like precipitation, the humidity, all these different values are more significant than the other things which you can capture through external APIs. So you bring in that information, you massage that information through clever um, strategies around that, and then you're able to do predictions. And now I talked about benchmarking, right? Now, benchmarking is a very clever way to make sure that you are not bringing in biases and you're bringing in more accuracy. Gentleman over there asked a question that how do you know that your predictions are right? Now, in order to know how your predictions are right, for every quarter of 2021, let's say, I have the data, I'm predicting against it, I'm comparing the difference, and I'm moving forward. I might have a bias in first quarter, I might not have a bias in the second quarter. So keep on going and forward. And then once you know that where the biases are, you optimize things, you tweak your models, you tweak in your hyperparameters, because that's what you can change. You can't change anything more than that. You can operate on things where um, what is in your control and what is not in your control. Basically, it's all written in Python. You have all these XGBoost libraries which are available, and you're using leveraging that ability, and you're capturing the neural network and predicting the model. And what you can do is you can use different analysis and the libraries which are available to help you get closer to your information and then do the prediction. So in this process, because we started from a POC project, there were a lot of challenges. First of all was we were only able to support small data. Then how do you support big data? Now in order to support big data, of course you have to scale vertically and horizontally. When you're scaling vertically and horizontally, you have to look into the fact that what is your cluster size. If you're using higher clusters, GPU computations and things like that, your cost goes up. But how do you bring it down? So what we did was we came up with a clever logic around that, is that we can use configurations based upon different environments and tiers. So if you have a customer which is a, let's say, small, medium, large, so based on that you can spin up different clusters and thus reduce your cost, because you don't want to always bring in your heavyweight clusters for a small scale customer and things like that. Similarly, this is kind of a strategy which has been applied. Then in terms of data sets, like we talked about data frame, loading the whole data frame for a big data in any cluster, what can happen is it can cause memory out of exception. And when that happens, you have to be mindful about that. How do you not get into that situation? Because data is constantly growing. Now, if you have given the solution to a customer, the data gets incrementally every year gets added, and added. How do you ensure that this information is properly managed, and you can't purge the information, because every data which you're capturing is important. And machine learning thrives and feeds on historical values. So you want to maintain, and the more the data you have, the more power you have to move forward with. But we have come up with a sweet spot of 5 years, which works quite nicely. And then we try to bring in the old value data which is older than 5 years into, let's say, from hot storage to cold storage, if you will. So that's the reducing the cost around that. So such strategies are used to reduce that. Now talking about the data, sorry. Okay. So yeah, that strategy has been used. Moving on. So why? So we talked about all of this, and Adapt is basically helping all our retailers in terms of forecast accuracy. We are getting more accurate forecast. We have a single source of truth, because we can show through reports and things like that, which no other solution provides them. Then retain demand and budget relationship. We provide a platform where the demand and the budgets can be correlated nicely. Control on demand, full audits, and a what if analysis. So all this thing in passing, helping a retailer decide and take an informed decision about the strategies. It name it being marketing strategy, sales strategy, and also expansion strategy. All of that they can use using forecasting tool, which helps them to take much more informed decision. So that's it.
We have maybe one question. You already, sorry, anyone else? Okay, Tom.
So I know when you're talking about points of interest, one thing that might be of interest is, let's say you're near somewhere that hosts events. Have you actually considered how those events might impact what the stores are selling as well, but not just in terms of the quantity of footfall, but the types of products and the types of people that might come in?
Well, we haven't done much analysis on events as such, but we have events in the stores. Those we can author them into the system, and then we can see what impact it has on the metrics. So that analysis has been done by our data scientists. External point of interest are very important because, let's say if you're closer to a theater, or let's say if you're closer to an amusement park, the likelihood of people coming to your store is less. So all those combinations can happen, and that's why we think that that driver we needed so to take much more informed decision.
Thank you. You have one more question?
Okay.
Short question, sorry.
Hi, thank you very much for your presentation. It was the tool is brilliant, I would say. So I also realized that this kind of tool is it's just my belief is that it's quite similar to SAP tools because they have their own clouds and stuff like that. So how can you say that these tools is different than SAP? Thank you.
Well, the reason why we say that it's different is the meat value. We give more accurate results. We have a lot of competitors in the market, but those competitors are not able to give the level of accuracies which we come up with. So that's our biggest USP right now. But things might change, but that's right how we stand right now.
Thank you, fantastic job. Really, thank you so much.